Hi everyone! Welcome in the video about monitoring in Eclipse Dataspace Connector. I'm Isa, and in this video I will guide you through an integration of Eclipse Dataspace Connector with Azure Insights to monitor telemetry data. Let's take a look at the topics that we are going to discuss today. First, quick introduction to the observability in distributed systems, followed by introduction to OpenTelemetry and micrometer. Then we will go through the content of sample 4.3 from the EDC repository. Next, we will see the demo with Azure Monitor, and then we will take a quick look into the EDC code. We will finish with a quick summary. Great, let's get started. Observability is an important capability of every system, but it's especially important in distributed systems, simply because they usually consist of many moving components communicating with each other either synchronously or asynchronously, which makes it very difficult to investigate issues such as performance degradation or some bugs. To overcome these challenges, we should make sure that our system is covered with three pillars of observability, which are traces, metrics, and logs. Let's focus first on traces. A trace represents an end-to-end request flow that goes through a distributed system. EDC uses an instrumentation library called OpenTelemetry that allows to export the telemetry data to different open source and commercial observability backends, like for example Jaeger or Application Insights. A metric, on the other hand, is a measurement about service captured at runtime. EDC uses a library called micrometer that provides a vendor-agnostic facet that allows to instrument the code to capture metrics. We are going to skip logs for now because this video focuses mostly on traces and metrics, but during the demo we will see also logs automatically collected in our observability backend. The demo is based on sample 4.3 in the EDC repository. Let's go quickly through the content of this sample folder. So this sample builds on top of the sample 4.0, which performs a file transfer from one connector to another. We have here modules for consumer and provider connectors. What they contain is basically Gradle build files that set up all needed EDC extensions and specify base runtime classes to run connector instance. Besides that, we have here contract offer JSON file that is going to be used to negotiate contract between connectors. Then we have file transfer.json file, which is basically a request to transfer a file. Then we have input file txt, which is a file that we are going to transfer. And then in Docker Compose YAML, we specify the consumer and provider connector services definitions, and we will run our setup using this Docker Compose file. This sample is built to run with Jaeger by default, Jaeger for traces and Prometheus for metrics, but we are going to use Application Insights as telemetry backend, so we will remove those two services from the Docker Compose file later. Instructions how to set it up you can find also in the last section of the README file. As a prerequisite to this sample, we need to have Application Insights set up in the Azure portal. Then we need to also download the Application Insights Java agent jar and place it in the root of our sample. This jar contains already the OpenTelemetry Java agent, which dynamically injects bytecode to capture telemetry from several popular libraries and frameworks. Let's go to our Docker Compose file now, and first we are going to remove all Jaeger and Prometheus related configuration. In the next step, we can replace the Open Telemetry Java agent jar with Application Insights Java agent jar. Next, we are going to specify environment variables for Application Insights. We need the Application Insights connection string that we can take from Azure Portal. We are going to specify also a name that will be visible in the Application Insights for the component and instrumentation logging level, which by default is set to info, but we will change it to debug. For better visibility, I will also add ports to the names of components. We are running here a simple scenario with single instances of connectors, but if you would like to run more complex scenario and add more services to this setup, you can also enable observability for each component, just repeating those two steps that we just did for consumer and provider. First, we need to build consumer and provider artifacts using Gradle build command. Then we will use docker compose app command to build and run the containers from the docker compose YAML file. And we added also an option to stop the environment if any container stops. We can see from logs that both consumer and provider are up and ready. So let's go ahead and trigger contract negotiation. We will use the curl command from the instructions. It sends a post HTTP request to consumer API with data from contract offer JSON file from the sample folder. In response, we got a contract negotiation ID. Let's copy it because we will use it later. And for now, let's switch to Azure Portal and Application Map. After refreshing, we can see our components. So when we click on Consumer, we can see requests that were sent to this service. Let's pick the one that we triggered, and now we are entering a view with performance insights. Here we can check, for example, requests count, but we are interested more in the traces for now, so let's click on drill into samples and pick our request. Here we can see the trace for our request with all the spans that were captured, and also with all spans durations. For example, this span represents the IDS message that was sent from the consumer to the provider to trigger the negotiation. And in the end, also we can see provider's response. We can also click on View All Telemetry to switch to slightly different view. This is more like an events view. You can see that our application logs are also visible here. Let's come back to the command line, and we will use now the ID that we have copied before to check the status of the contract negotiation. Let's copy the get curl command from the instructions and add the ID as path param. And now let's run it. In the response, we can see that the state is confirmed, so the negotiation between connectors is established. It means that we can trigger now file transfer. We need to copy the contract agreement ID and use it in the file transfer JSON. It will replace the placeholder. Finally, once it's done, let's post the file transfer request to the consumer. Let's switch to Azure Portal, but now we will take a look at different possibility to get to traces. Let's open Transaction Search, and here we can see all different transactions, including, for example, requests, traces, and exceptions. We can apply also some filters to narrow down the view, and let's apply filter by request URL path. We will pick the one that we just called, a transfer process, and then we can see the requests on the top in the request list. By clicking on it, we'll be forwarded directly to the view with the traces. This trace shows the whole transfer process flow, including the IDS communication between consumer and provider. In this scenario, we have single instance connectors, so we have two actors here, consumer and provider. But in case we'll have some parts of the connectors running, for example, as separate runtimes, we'll see them here as separate actors. This way, we can track different execution flows in the data spaces modeled even with very complex distributed systems. So that would work even if we have multiple tracing vendors in place, because the tracing context, which by the way contains, for example, the operation ID that you can see on the top of the trace here in this view. So this tracing context is sent out within the HTTP requests between the components. And this tracing context is standardized, so every vendor can interpret the tracing information the same way. We took a look at traces. Now let's see metrics. In the drop-down, we can see many different metrics, for example, from executor service or instrumented libraries like Jetty. We have also JVM metrics with data about memory usage, for instance. Besides that, system metrics like, for example, CPU usage. Let's pick now OK HTTP request count metric. We can see here 2 calls in last 30 minutes, which is true because in our setup we have only consumer instrumented to send metrics, and during our demo, consumer sent 2 requests to the provider using OK HTTP. Okay, so now we are ready to take a quick look into the code to see how the observability is implemented in EDC. To enable collecting metrics, we need to add a micrometer extension from core modules to the dependencies in our connector. This extension adds to the meter registry some metrics available from micrometer library. For example, system metrics such as class loader metrics, JVM memory metrics, JVM GC, or processor, or JVM thread metrics. Also OK HTTP client metrics, and it also adds instrumentation for the executor service so that we can also monitor the status of the executor service pulse. So these are metrics that we are getting by default only by adding a micrometer extension to our project. But besides that, to enable other metrics, we can use other custom extensions. In our example, we can see HTTP Jersey micrometer and HTTP Jetty micrometer, which provide metrics instrumentation for the Jersey framework and Jetty web server. You can find the information about metrics in the markdown file called metricsmd in the docs folder. Please note also that metrics, all of them or only specific groups, can be enabled or disabled using properties. By default, all of them are enabled. The tracing is built in the EDC core components, so doesn't require any additional extensions to enable it. Some of the spans that compose traces are created by automatic instrumentation. OpenTelemetry provides automatic instrumentation to many well-known libraries and frameworks. In some situations, for example, in some async processing cases or for better granularity of traces, there's a need to manually create custom spans, and these are also present in EDC code. Custom spans are specified using with span annotation. They are created for operations such as state handling methods or resource provisioning or deprovisioning. More information about the tracing concept in EDC and the reasoning behind it you can find in the docs under Decision Records folder. In this video, we went through instructions to set up observability for EDC connectors. We took a look at OpenTelemetry and micrometer libraries used in EDC to provide vendor-agnostic monitoring capabilities. We used Azure Applications Insights as telemetry backend, which was configured in roughly 2 steps. First, adding Java agent to JVM runtime to all EDC instances, and then using environment variables to set up connection string, components, names, and so on. I hope you liked this video and thanks for watching.